Let's start off. Chalo, cams on everyone. Let's start off. Great. Let's start off with a question. So last class we have seen, if the bodies have same acceleration, we can use the net force method. But like I said, it has its own limitations. If the acceleration magnitude is not constant, you can't do this. Let's say we have a block of mass m. Here we have another block of mass, 4m. This is the ground. Initially, both the blocks are at the same height. This side is 1 meter. Now, when you look at the picture, right, looking at the picture only you can get a feel, right? Both the blocks don't have same acceleration. We don't know exactly what is the value, but I'm that much sure the acceleration is not same for both. So initially blocks are released from rest. First question, find the acceleration of the blocks. Find speed of the blocks. When 4m is just about to hit the ground. If 4m hits the ground and stops. Find maximum height reached by the m block from the ground level. Okay, let's start with the first one. Get the remaining also, Samyak, Ishma. Let's see how to do this. Remember the process. What was the process? Step 1, choose your system, draw the FBD. SN accelerations, find relation between them using constraints. Step 3, choose your coordinate axis system, resolve the forces and accelerations. Apply F is equal to ma for each block and solve. The process is still valid. Try. I'll give you 1 minute for the first part. T is not given, right, Aditi? T is something which you have assumed, right? Tension. You should not give answer in terms of T. Others, you need to keep your cams on or else you'll be removed from the classroom. नहीं यार, those are not the answers. Neshman, that's not right. Get me the maximum height, na, Samyak. Let's see the first one. Step 1, choose your system, draw the free body diagrams. So on this, we have tension T. So it is the same string here. So this will be T, this will be T. So this will be 2T. The weight will be 4 mg. This weight will be mg. Let the accelerations be A1. Let this acceleration be A2. I don't think they're equal. So I don't know, let it be A1 and A2. So step 2, find the relation between them. Constraint method, T into A1 plus tension 2T into minus A2 is equal to 0. So we have A1 is equal to 2A2. This is the relation between the accelerations. They're not the same. No, Samyak, that's not the answer. Ishman, get me the answer, na? Get me the height. Okay, let's see. So once you got the acceleration, you're done. Write the equations for the first block. We'll have T minus mg is equal to mass into acceleration. For the second block, we can write 2T minus 4 mg is mass into acceleration. I am taking up as positive, down as negative. So anything that is pointing down is a minus sign for me. Again, like I said, I'm keeping the convention simple. You're done. So substitute here. So T will be mg plus ma1, but a1 is nothing but a2. So 2 ma2. Take this and substitute here. This will be 2 into 2 ma2 minus 4 mg is equal to minus 4 ma2. Bring all a2s to one side. This will be, yeah, this will be 2 mg minus this. This will be 2 mg. This will be minus 8 ma by 2. So from here, we get a2 is equal to g by 4. If a2 is g by 4, then a1 will be 2a2, which is g by 2. Check your accelerations, everyone. See where the equations went wrong. Nish, man. You have to see from the ground level. Clear with this? Question still not over. What is the second part? Find the speeds when they hit the 4m is hitting the ground. How do you do the second part? Find the speed of the block when 4m is just about to hit the ground. So okay, so this distance is 1 meter. Your initial speed is 0. And we got the acceleration a2. Since the acceleration is constant, I can use my kinematics equations. V square minus u square is equal to 2as. So this will be v square. Initial speed is 0. 2. Acceleration of this block a2, which is g by 4. And displacement is 1 meter. So we get v square is equal to, that's 20 by 4, or you can just simply as g by 2. Is that clear, everyone? Root 5 meters per second. This is the speed of the 4m block. And we know from constraints, velocity of the block m is 2 times velocity of the 4m block. Therefore, velocity of m will be 2 root 5 meters per second. So there's no need to solve for it separately. There, once we get the accelerations from there, you can find the speeds. Now, what about Hmax? Now, the third part of the question was find the H max when the 4M hits the ground. Most of you are getting three. I don't think three is an answer. Let's see where you're goofing up. Listen to this explanation. Let's draw a picture. Always start with the picture. The more you can explain, the better. So initially your scenario was here. This is 4M. This is 1 meter. So this was the initial level. So when this 4M hits the ground, we saw from constraints, whenever 4M moves 1 meter, the M moves 2 meters. That was fine. That means this block here, M. So when this has fallen 1 meter here, this 2M will go 2 meters. Is that clear? So the thing is this way. Now you tell me, when 4M comes to and hits the ground, do you think M will stop suddenly? Are you getting it? When 4M stops, M will not stop. M will still have velocity. So velocity of M, which we calculated here, is 2 root 5 meters per second. That was the thing. So when 4M hits the ground and stops, 4M stopped because the ground was hitting you and you're stopping, but there is no one to stop M here. M will continue with its velocity. The string becomes loose. Continuing going upwards and string becomes slack. You can focus on solving and listening. Don't worry about the notes. You'll get the PDF. So focus on solving the questions. String becomes slack. That means the next picture will look like this. You have a loose string like this. The 4M has hit the ground. So from this level, the block will go up like a projectile motion. Here it will come to rest. So we know this formula is V square by 2G, isn't it? Which comes out to be 2 root 5. That is 2 will cancel. This is your H here. So H will be 4, 5 by 20, 1 meter. So there. So this block will go to a total height of 4 meters. So it is already 1 meter above the ground. When 4M comes down, it will go 2 meters and then it will continue to fly up like a projectile. Therefore, the maximum height will be 1 meter from the ground, then 2 meters, and then 1 meter more. Total 4 meters. Is that clear, everyone? Right, Srihari. Right, Utsa. Now you guys got it. Any doubts on this? Arya, Ishman, got the mistake? It doesn't stop. That was a catch there. So when 4M hits the ground, 4M will stop, while M will continue to go up. Any doubts on this? There, like I keep saying, follow the process. Choose a system, draw the FBD, assign accelerations, find the relation between them. Choose your coordinate axis, resolve the forces, apply F is equal to ma, solve. As long as you know the process, everything will fall in place. Let's see one more. So if you see the last method that I taught you, right, net pulling force method, you cannot use that here. So you have to go back to the standard thing. This is another good one. We have 3 blocks here, 3M, 2M, and M. All released from rest. Find acceleration of the blocks. Got an answer? Do type in the chat box here to the co-host. Let's see. It's like standard brute force method, like FBDs, constraints, equations, solve. Then I'll show you something better. How can you handle this much faster? But first, always let's do it in a normal way. Nee, sure, yeah, that's not the answer. G by 3 for what? There are 3 blocks. And that is anywhere wrong. How do we start? You start with the free body diagram. I'll help you with the free body diagrams here. Step 1, draw the free body diagrams. So start from somewhere at the bottom. Let the tension be T. If that is T, this is also T. Then this tension will become 2T. And this will be 2T. This has a gravity, mg. This has the weight, 2 mg. This has the weight, 3 mg. There. This is the FBD. We are just writing the forces. Nee, samyak wrong. Utsa wrong. Arya, you got something, but what the hell did you do? I thought you were close, but you did something else. Acceleration में m का term आएगा नहीं रे God. Dimensions are not mass.
Sir, no, that's mass for the specific masses.
Okay. Mm, let's see. I don't think that is right. Let's see. Anyway, got the FBD. Next thing, step 2, assign accelerations. Let this go A1, let this go A2, let this go A3. How do I know it is going up? I don't know. So I'll assume any direction I want. The signs will take care of themselves. You don't worry about it. If A1 is not actually going up but down, final answer will come negative. So assign whatever you want. You can take all up also. This is your step 2. Remember, there is no guarantee all will have same accelerations. Another mistake what people do, they think, sir, this is 3m. So this is also looking at 3m. So the block won't move. That is not true. Getting it? When these pulleys start moving, this will not act like a 3m block. We will see that it acts like what? No, Kanish, that is not the answer. So then step 2, we got the accelerations. Then find the relation between them. Constraint equation. T1 A1 plus T2 A2 plus T3 A3 is 0. So for the block 1, tension T into A1, second block T into A2, third block 2T into minus A3 because it is going down. Up positive, down negative. Keep the convention simple. A1 plus A2, right, is equal to 2A3. This is the relation between the accelerations. Equation 1. Then apply the F is equal to ma for each block. Ishwan, that's not right. So for the first block, T minus mg is equal to mass into acceleration. So from here, I will get A1 is equal to T by m minus g. Second thing, T minus 2mg is equal to 2m into acceleration. So this A2 will be T by 2m minus g. For the third block, 2T minus 3mg is equal to 3m into minus A3. So we get A3 is equal to G minus 2T by 3m. Why am I doing this? Because I know A1, A2, A3, I can put it in the constraint. So take these three equations and put it in equation 1. Now when I do that, so A1, if I substitute there, I'll get T by M minus G plus T by 2M minus G is equal to 2 times G minus 4T by 3M. This was your equation 2, this was your equation 3, and this was your equation 4. Bring all T's to one side. That will become 1 plus 1 by 2 plus 4 by 3. Bring all G's to one side, that becomes 4G. From here, we get tension is equal to 24 mg by, that would be 3 by 2, 3, 3, 9 plus 8, 17. That is your tension. Now, once you got the tension, take them and put them in equation 1, 2, 3, 4. So if I substitute this in equation 2, 3, 4, so A1 will be how much? T by M minus G. So M goes off. 24G by 17 minus G. 24 minus 17 is 8G by 17. Acceleration 2. T by 2M, that is 12 by 17 minus G minus 5G by 17. A3. G minus 2 by 3. T by M is 24 G by 17. 3s are 8s are G by 17. There, those are your accelerations. So A1 is positive, means my assumption is right. A2 is negative, my assumption is wrong. 2mg is also going down. A3 is positive, my assumption is right, it is going down. There, these are your accelerations. Not a good numbers, but that's how you solve. Sure, yeah.
So it's like my answer was getting wrong because I did the mistake in that step only in which you wrote A1 and A2. Now I assumed they both have the same acceleration for some reason. I don't know why.
So now you know, no? That's okay.
Yes.
Any doubts on this? Clear with the process? Like I said, this is completely like, see, I didn't do anything new. I just followed the process. I wrote the FBD, I wrote the constraint, I wrote the equations, I solved. Keep it as simple as possible. Getting it?
Sir,
But this will still take time. Aditi.
could you explain how you got the relation between the three accelerations? I didn't understand.
You forgot the constraint equations. Don't know how to do constraints. Tension into acceleration, T1 A1 plus T2 A2. Yeah, that is the whole thing we did for almost 2.5 classes. How can you forget that?
No. Okay. I don't know what I was thinking there. All right.
Yeah, remember, this was the thing.
Yeah, no, I remember. Oh my God. Okay. Yeah.
Happens. You still didn't have your dinner. That's why. Next thing. All got this thing? Won't A1 be 7G by 17? Maybe I could do a calculation mistake. 437 na sahi bol rahe. See, after doing this much, you do a calculation mistake. Getting it? Now, this is still lengthy. There's a much better way and faster way to handle this. So listen to this one. But I hope everyone got the standard process. We call this thing fully equivalent. Now, if you take a Atwood machine, M1 and M2, we calculated this before. If this tension was T, we know the tension is 2 M1 M2 by M1 plus M2G. That means the tension in the uppermost string will be 2T. That means if I replace this entire pulley with one big block, which I'll call it as M equivalent, and if I make sure the tension in the string is same as 2T, so where 2T will be equivalent to M equivalent into G, this will become 4M1 M2 by M1 plus M2G is equal to M equivalent. So you can replace this pulley with the two blocks with one single block. Because tell me one thing, does the ceiling care whether the tension 2T is coming from a single block or from a system of blocks? The ceiling cannot tell the difference between both of them, isn't it? So if I replace that whole pulley with this block, so M equivalent 4 M1 M2 by M1 plus M2, they will behave the same. So 4 by M equivalent. So you can replace the pulley with this, not 3M. You can't directly add the masses. This is your pulley equivalent. And the best thing about this is valid even if the pulley is accelerating. We can prove that, but it will. So even if the pulley is accelerating, it still works. But remember, it will work only when you have a pulley and block. You can replace this part. If you have any other variation of this, you can't do this. Right? Clear with this? Now let's see the old question, the previous one, how to do that. So this is your 3M. This is 2M. And this is M. So if you look at this system here, this would look like a pulley and this thing. This is your Atwood machine there. So I can replace this with an M equivalent, which is 4 into 2M into M by 2M plus M. That turns out to be 8M by 3. So this whole problem becomes into a 2-block problem. This is your 3M and this is your 8M by 3. And then if there are 2 blocks, you know what to do. Acceleration, acceleration. For the Atwood machine, you know the formula from here. 3M, M2 minus M1 by M1 plus M2. Or you can directly solve it also by G. This turns out to be, again, 9 minus 8 with G by 17. Faster. You can even find the tension here. So here tension will be, what is the formula there? 2 M1 M2 by M1 plus M2 G. That would be 2 into 3M. That is 8, 16, M3, 48, mg by 17. So that would be the tension in the uppermost string. So on this string, if the tension is T, then this string ka tension will be T by 2 and T by 2. Just put one more pulley here, Nare, over here. Then it is gone, na? It is not an Atwood machine anymore. We should have 2 blocks hanging there, right?
So then we can use the same method twice, right?
Where? Which method?
So this M equivalent method, if there was one more pulley.
Like I said, na, if M equivalent ke liye, it should look like this. If you make something like this sort, let's say we have a block here and we have one more here, and let's say here, if I keep it like this, a string, not a block. Getting it? Then you can't do, na?
No, sir, I was saying like we put one more pulley instead of the block.
Then you can do for this, and then you can do for this. You can keep on doing it.
Yes.
That works. We will do a thing like that. All got this? So this gave me the acceleration of 3M block, but how do I find the acceleration of M and 2M? There, I know M and 2M, right? So this is mg, this is 2mg. So you can find the acceleration for them separately. T by 2 minus mg is M into A1. Substitute T ka value, you'll get the answer. T by 2 minus 2mg is equal to MA2, 2MA2. Once you get the tension, you can draw single, FBD of each block and you can get the accelerations. Clear the pulley equivalent. So this saves your time. Have a look at the method once. So let's see one problem based on this. So this is also fine, but you can see we have to solve 4 equations. This thing kind of saves time. But then again, remember always, whenever you have a shortcut or a technique, right? Always remember, where it will work, where it will not work. So blindly, if you remember, you will have a problem. It saves time, but that's your catch. Arya.
Sir, if you see with respect to the pulley which was hanging on the string, like the bottommost one, will the blocks 2m and m have same acceleration?
No.
What for
They
opposite
don't have, see, if this point is fixed, then it will be. If you're saying if I'm going to stand on the pulley, then it will
Yes.
be. Yeah.
Sir, so we can solve this question if we assume a plus that acceleration with respect to pulley and a minus the acceleration with respect to
Kar
pulley.
sakte hai. Yeah.
And then we will put in the constraint
Same thing, na?
relations.
But end of the day, number of variables are not decreasing, right?
Yes.
So if the number of variables are not decreasing, you'll get the same number of equations. So calculation wise, it really won't help you. Point is always that. Always think that by choosing something new, are you decreasing the number of variables? If you're not decreasing, then it really won't make much of a difference. But yeah, your method is not wrong. It is right only. You can do that. All clear with this? Now, using this, you tell me what is the answer for this one. Let's say this is 1 kg, this is 4 kg, this is 2 kg, and this is 3 kg. Find the acceleration of the blocks. Now, if you try to use the regular method, then you'll have 4 FBDs and 1 constraint, so 5 equations. See if you can try to use the pulley equivalent. Everyone should try. Rudransh, give it a try. Solve. Everyone should try. At least get a wrong answer. That is fine, but try. If you're just waiting for me to tell the answer, you won't learn anything. So how do you start? Take this whole thing as 1 equivalent and 1 equivalent. There it would becomes your regular Atwood machine with 2 blocks. Then see from there you can do something.
Sir, can you give like 1 more minute, please?
I'm giving you. Where am I running away? Solve. You're wasting time by unnecessarily asking. Solve. Someone is confused with the question. Something you didn't understand. Please ask. Question is clear. Go ahead. I'll give you a minute more. Point 2G. Srihari, there are 4 blocks. So which one are you talking about? No. So A1, A2, A3, A4. Give me all 4. G by 5, 3G by 5. Ishman, see. One. That's a blunder. Matlab, you can just see and tell it's a blunder. Why? Imagine, Ishman, if there are no strings connected, and if you leave the block, it will fall with what? G. Right? So you can't have an acceleration greater than G, isn't it? Make sense? So that is one thing. When you get an answer, maybe you don't know it is right answer, but you should know when it is a blunder. When strings are connected, you cannot fall faster than G. Maximum you can fall with G. Acceleration of 1 is 3G by 5. Okay, let's see. Let's take up the Pauli equivalent. Continue solving. By the time I explain all this, you'll get another 2 minutes. So this is one Pauli equivalent and this is one Pauli equivalent. So I'll just call this guy M1, which is 4 into M1, M2 by M1 plus M2. That is 16 by 5 kgs. This let's call it M2, which is 4 into 2 into 3 by 2 plus 3, 5. That is 24 by 5 kgs. Numbers are not great. So this whole thing becomes like your Atwood mission again. 2 blocks where this mass is 24 by 5 kg. This is 16 by 5 kg. So I'm actually more interested in finding the tension. You will see why. So what is the tension for an Atwood mission? 2 M1 M2 by M1 plus M2G. So 2 M1 M2 by M1 plus M2. 16 by 5 plus 24 by 5. This would be, how much is this? Bottom becomes 40. That will be 2, 16, 24 G by, that is 40 by 5, so 8. 8's 2's that would be 96 G. This is your
I think
tension.
you missed out the 5.
I missed out, there's a 25 also sitting, na?
Yes.
It's a source now. I got very huge tension. Great. That's your tension. I hope that is right. Clear? There, I got the tension. Now what? Utsa got 2G by 5, 43. 43 aa gaya re, Utsa. That's pretty big value, right? Just now I told you can't be greater than G. 23 by 25, 13 by 25. Okay, there I got the tension. Now what to do? Can you try? I'll give you 1 more minute. Again, Arya, abhi just now we are discussing. You can't have an acceleration greater than G. A simple logic. Mg is pulling down, strings are pulling up. So the Mg minus tension is Ma. So you will definitely get less than G. Your answer 25 by 23 is greater than 1. So once you got this, what you do? So where did you find the tension? Remember, you found this tension, which was 96 G by 25. So if that was tension, this will be T by 2. This will be T by 2. This will be T by 2. And this will be T by 2. This will be 10, 40, 20, and 30. Done. So for each block, just find the acceleration. So for 1 kg block, the tension will be T by 2. This will be 10. Let the acceleration be A1. T by 2 minus 10 is equal to 1 into A1. Substitute the values. You will get the answer from here. How much is this? 96G. So that is 48 by 25. 48 minus 25 is 23 by 25G. You wrote reverse. Similarly, you do for the 2 kg block, 4 kg block. This is T by 2. This is 40. Assume all are going up. Doesn't matter. The signs will take care of it. T2 minus 40 is equal to 4A4. Similarly, I can do for the 2 kg block, T by 2 minus 20 is equal to 2A2. T by 2 minus 30 is equal to 3A3. Substitute the values, you'll get the answers from here. I will leave it to you. That's how we normally do. Once you get the tension, just take the individual blocks, draw the FBDs, and get the accelerations. All clear with the steps? Yeah, all these are accelerations in the ground frame. Okay. I didn't do anything in the relative frame. No, I found tensions, everything in the ground frame. All these forces are in the ground frame.
Pulleys are also accelerating by
Why do I care? Now see, if I ask this block, what are the forces on it? What will that say? I have T by 2 up and mg down. Are there any other forces? So why do I care? Like net force on the body is equal to mass into acceleration of the body in the ground frame. It's already taken care of that. Pulley, when you have to take care, if I'm saying if I'm standing on the pulley, then why will I write A1 and A4? No, I will write this is going up and this is going down, isn't it? I didn't do that, no? I took all the blocks accelerations A1, A2, A3, A4. Making sense? And if you see here, I didn't teach you pseudo force yet, so we're not getting into that. First answer be negative. I don't know what you mean by that. I got positive. A1 is positive. Means it is going up. All clear with this? Any doubts on the pulley equivalent method? So saves you time, quite useful. Let's see one more. So again, what did we do? We replaced both the sides with 2 blocks. We got a 2-block system. We found the tension. Then we split the tension. Then we drawed, each block FBD, and then we got the accelerations. Let's see one more. Let's say we have a block of mass M. We have a block of mass M. We have a block of mass M. And so on till infinity. We have infinite pulleys. It's a never-ending branch. All the blocks have same mass. Let's say this block is going up with A. Find A. How do we handle this? Think for a minute, then I'll tell you something, then I'll give you more time. This is a method where pulley equivalent really works, helps a lot. This problem, right, is actually inspired by a max problem. Did you guys do this problem in max, maybe in school or something? Y is equal to root over x plus root over x plus root over x plus and so on till infinity. Did you do any question like this? And then the question was find y or something like this. Now think about it. This problem was actually inspired from this mathematical equation. You will see something similar to this again in resistors later on. So anyone remember how do we do this? Then we will say since the whole thing is y, if you leave one branch, that is also y. Then we'll say this is root over x plus y. Because infinity minus 1 is still an infinite branch. Then we square it. Then we bring it to one side, we get a quadratic and we solve. So how do we use that here? Think, take a minute or so. It's not GP routes, huh? नहीं रे यार ये G कैसा आएगा? See, let the whole thing. So we don't know what is this branch on the right hand side. Let this whole infinite branch, let it be X. Remember, I can't use Pauli equivalent for this directly because Pauli equivalent I'm using only when there are two blocks. There are infinite blocks hanging here. So I don't know what is that, but let this be X. Now listen to this statement. If this whole thing is X, if I leave one branch and if I go here, this whole green thing, isn't that also X? Do you agree with that statement? The whole thing is X. Then if I leave one branch, it still looks like X only. Right? Oh, yeah, you got it. This is also X. That means now when I try to draw this, so we got a block of mass M. And here we have a block of mass M. And this entire green thing is your X. But you said this whole thing was also X. Isn't it? This whole thing was also X. That means the Pauli equivalent, M equivalent will be 4M into X by M plus X must be equal to X. Because this blue one, so this whole branch must be X. X and X will cancel. You end up with X is equal to 3M. That means this infinite branch which you're having here is equal to a block of mass 3M. So you can replace this whole setup on the left right hand side. This is M and this is 3M. This becomes a simple Atwood machine. So this is going up with A and this is going down with A. Acceleration is equal to 3M minus M by 3M plus M into G. G by 2. Is that making sense? I think now most of you got it. Understood what we did? I said let the whole thing be X. It's an infinite branches. So if I leave one branch from the top, it still looks like X only. There is no change. So the green one is also X. Now the picture becomes like this, an M, M and an X. But this entire red box is also X. But the red box contains one M and one X. So the resultant of M and X must be again equal to X. So we get X from there. Making sense? That's how we solve this infinite Pauli's. Can you find the acceleration of, if I ask you to find the acceleration of this block, how will you find?
So take the M equivalent for that one and then solve.
That will become long, right?
Sir, it will be same, right?
नहीं, same नहीं होगा.
So G by 4.
Guess कर रहे हो, solve किया.
So guess.
Solve करना. Try to find the acceleration of this block and see. They'll actually all form GP now. G by 2, G by 4, G by 8, and so on. All got this? That's how we do the infinite Pauli's. So Pauli equivalent is pretty useful. So this is one thing there. Now we can have a more generalized solution for here. Like I said, right, you can, the more shortcuts you get more things. But there is one more generalized way if you have a lot of strings and a lot of blocks, right? And there's a way to do. Quite complex. Even I use this rarely, but still we will have it one more method just in case. So let me prove it first. So let's say there are n strings. With n different blocks. Meaning I don't even know how the system will look. I'm assuming everything random, matlab n blocks, n tensions and everything. So C1 into T is the tension of the first block. So that C1 is the coefficient. Cn into T is the tension in the nth block. So C1, C2, C3, C4, this will be the tension coefficients. Mn is the mass of the nth block. An is the acceleration of nth block. So then we use our power method for the constraint equation. Or your virtual work method, whatever you want to call it. What does the virtual work method says? Tension into acceleration, the product is sum should be 0. So C1 into 2, T, tension into acceleration. C2 into T2, tension in the second block. C2 into T, acceleration. So on, Cn into T, acceleration must be 0. Remember, there is a problem with this. You can use for acceleration only if the angle does not change. This is valid only when only strings are present. If you have, remember the method 3 which we did, the blocks are pushing each other due to normal reaction. We can't handle them with this. Only when strings are present. And the angle between tension and acceleration should not change. If the angle changes, you can't use this constraints for acceleration. So basically, they should be parallel. Now, if you take any one block, Mn, the forces on the block will be Cn into tension. The gravity is mg. Let the acceleration be an. So from here, we get a general equation Cnt minus Mng is equal to Mna. Meaning, if you can remember, great. If you can't remember, it is fine. With whatever I taught you till now, you can handle most of the questions. But this thing has its own merits, so we will see. This is your An ka general formula in terms of Cn. Now take this An and substitute in this formula here. So take this An from here and put it in this. Then your formula becomes C1T by m minus g, C2T by m minus g, so on, Cnt by m minus g is equal to 0. Now bring all t's together. We get t square. We get C1 square by m1, C2 square by m2, so on till Cn square by mn. Bring the g to that side, you will end up with minus gt, C1 plus C2 plus so on till Cn is 0. There. So this method actually gives you the tension. So tension will be C1 plus C2 plus Cn, which are the coefficients of tension. I'll give an example, don't worry. By C1 square by M1 plus C2 square by M2 Cn square by Mn. So this can be written as sigma Ci G by sigma Ci square by Mi. There. So what is this T? T is the tension in any string that we choose. So assume T in some string, whatever you want, and start the problem from there. Tension in any string of our choice.
So in the first line which you wrote on this page, it should be M1, M2 till M2.
M1, M2 tha.
Okay.
Right. So what is Ci and everything? So C is the coefficient of tensions. Right. Again, remember, use this only if you have tensions and gravity. There should be no other forces. If you have normal reactions, blocks are pushing each other and all, this will go off. So what we did here, right? Literally, we filtered out everything. Let me show an example. Matlab, you will lose all understanding, but you will get the answer. I think you can put down that thing in the red box. Note it down. You will need that. We will do a few problems based on that formula. Note it down. You won't remember. Let's see. Copied. So let me take an example. The same problem which we did already. Let's use that only since we already know the answer. 3m, 2m, and n. So listen carefully how to use this method. Start from anywhere. Choose any string that you want. Okay. So I will choose this tension is T. If that is T, this will be T by 2. This will be T by 2. You could have taken the bottom also too. Next thing, get the coefficients. What is the coefficient of this tension? This coefficient of this tension is half. So it is half into T. So this coefficient is also half. That coefficient is 1. Now try to get the formula. What is the formula? Tension is equal to C1, C2, C3, the sum of the coefficients into G by coefficient square by M1. So you can choose anyone as M1, anyone as M2 and everything. C2 square by M2, C3 square by M3. Now, Srihari, is that clear? Coefficient of tension? Understood? Where are you?
Yes, sir. What is coefficient of tension, sir?
Yeah, please keep your cam on. No?
Yes, sir.
So what is coefficient of tension? If it is T by 2, so what is T ka coefficient here? Half into T. That is your coefficient.
Okay, sir.
Getting it? So if you have only T, then 1 into T, 1 is the coefficient. So anything in front of that T, that number is the coefficient. Okay? So I will take M as M1. So coefficient is half plus 1 into G by the first block coefficient is half square by mass M. So you take the any block. So we have to take that coefficient by mass plus half square by mass plus 1 square by mass 3m. Simplify this. This will be 2g by how much is this? This would be, the m goes up, 1 by 4 plus 1 by 8 plus 1 by 3. That would be 2 mg by 3 by 8 plus 1 by 3. That will become 48 mg by 17. This is the tension. So this tension is 48 mg by 17. And this block ka mass is 3 mg. Let the acceleration be up. Then T minus 3 mg is equal to 3 ma. Substitute and solve this. You'll get A is equal to minus g by 17, means it is going down. Did you see what we did? I got the tension in the string without doing, no solving, nothing there. That was the tension in the string. So I solved this problem in 3 different ways. One, I used a regular solving. This will always work. Then I used pulley equivalent. Then this is a method, this thing is like completely filtered version. There is no understanding, no FBD, nothing. You'll get the tension in any string. But the headache is you need to remember that. So in any block, you want a particular tension in a particular point of the string, you can use this, you'll get the answer. Are you clear with this? Let's see a few more examples on this after the break. But any doubts on this page? Take a break. Come back by 9:39. Let's have a 5-minute break.
Sir,
Any
can you
doubts so
show
far?
the
Please
previous
ask.
page, sir, again? Yes, sir. उससे भी पहले.
You're not there in the class. Where are you going?
Yes, sir. This one, sir.
Others, any other doubts? Go, take a break. Come back in 5 minutes.
Okay, sir.
There, let's start off. Come on, everyone.
Sir, can we use that method which you taught right now for systems like these?
इसके लिए था. So here, if you try to use now, I can't use fully equivalent. I can use a general method, but there'll be 4 equations. It gets really messed up. So see, there are only strings connected here. Then this will work. This formula works. So when you have a complex, 4 or 5 blocks and all strings are connected, then this method really works good. Other scams on? Let's solve this. So again, what are the steps? Start with the tension anywhere, let it be T. Now, since you want to find the acceleration of that particular block, it is preferable you take this guy as T. If this is tension, and this is tension, so this must be 2T. So if that is T, this is also T. And this will be 2T, this will be 2T. Hope that was clear. Srihari, now you tell me, what is the quotient for this guy?
Sir, 1.
1. No? This quotient will be
2.
2. And let this quotient be 1 again, and let this quotient be 2. Got it? Now you know how to get the coefficients. And there, once you got the coefficients, the tension ka formula is sigma, the sum of the coefficients into G, by sigma coefficient square by particular mass Mi. Substitute there. So coefficients is 1 plus 2 plus 1 plus 2 by G. For the first block, the coefficient is 1 and the mass is 1. So that's 1 square by M. Second block, the coefficient is 2, mass is M. Third block, the coefficient is 1, mass is 2M. Fourth block, the coefficient is 2, mass M. I hope that's making sense. 13G by 19, 7G by 19, G by 3. We have 3 different answers. So let's calculate. How much is this? That will be 6 mg by 1 plus 4 plus half plus 4. This will be 12 mg by, that is 9 to 18, 19. I got 12 mg by 19. Now take the block. Forces will be tension, mg, acceleration. 12 mg by 19 minus mg is equal to ma. This gives you acceleration is equal to minus 7g by 19. So it is not going up, it is coming down. Check your calculations, everyone. Right over here, right, Samyak? So I think now you got it. Others, see where it went wrong. But is the method clear, everyone? Saves you time when you have multiple strings and multiple blocks, right? It saves you time there. Clear with this? There, that's a few problems based on strings and all that stuff. So let's go to some other different models. So there, I taught you three different methods. The regular one, then you can use your fully equivalent, then you can use your this tension thing.
So if instead of 1, 2, 1, 2, we use half, 1 and half, will we get the wrong answer?
No, when you say half, one and half, like why are you using half exactly? Where did you take tension T as?
I took the 2 as 1. I took,
This one as T.
yeah.
T, and then you'll get the same thing, but then you'll get the tension here, no? You won't get this tension.
Oh, in the end I didn't. Okay, yeah. Got it.
Right. So you need to find this tension, right? So if you got this thing as T, then this will be T by 2. Fine, you'll get the answer.
And divide by 2, yeah. Got it.
So that's what I said, right? T is the tension in whichever string you have chosen. This you have already seen. This is the third time you're saying. You saw the first time in constraint, then you saw in three-body diagram. This is small m, this is capital M. All surfaces are smooth. Find the acceleration of the blocks. Again, remember the process. Step 1, draw the FBD. Step 2, assign accelerations and find the relation between them. Step 3, apply F is equal to ma. Step 4, solve. Let's see whether you got the FBD right. And for constraints, right, you can actually check out here. There, this was page 41. We have done this here. So step one, free body diagram. Remember, you always include the pulley with the system because it is fixed to it. So how many forces are there? The string is pulling here, T. The most common mistake, people forget this tensions here. They don't include this pulley here. That is the thing you have to be careful. Normal reaction. There is one tension here. Your own weight. There is one normal reaction from the ground. Total 6 forces. The small block, tension, weight, normal reaction. Please check your free body diagrams. See if you missed out any forces. That is wrong. Step 2, assign accelerations. I'll assume the big block is going with A. Then we have seen this in constraints. If the big block is going with A forward, the normal reaction pushes you forward. So you'll go with A forward and you'll go down with 2A. Remember this? So whenever you push the block by X forward, you can notice here, the string gets loose at 2 different positions, X and X. All this loose string has to go somewhere and the only one who can take it is block A. So whenever the big block goes forward by 1 meter, the small block goes down by 2 meters. So this was the thing which we got. Hope everyone remembers this, the constraints. So acceleration will be A into A. Step 3, write the forces. So for the big block, horizontally the forces are T, 2 tensions, minus normal reaction is equal to mass into acceleration. For the small block, tension minus mg is mass into minus 2A. I am keeping it simple, up, positive, down, negative. And horizontally the forces are N is equal to mass into acceleration. There you got everything. So this will be T is equal to mg minus 2ma and N is equal to ma. Take this and substitute here, take this and substitute here. So you end up with 2 times mg minus 2ma minus normal reaction is ma is equal to capital Ma. Be careful with that. A's are different. So from you'll get A is equal to 2 mg by capital M plus 4 small m. There is some more 5m actually. See where it went from. Right, Arya, you got it. Are the steps clear, everyone? Main thing, get your FBD right. You missed one force, the whole thing will go for a toss. Then get your constant equation. Then it is just a matter of writing equations and solving. How did I get the first one? Which one, Vanshika? You can just unmute and tell 2t minus mg. 2t minus mg. Where 2t minus n? This one, na? See. Tension, tension, normal reaction. Forces in the horizontal direction. So 2 tensions are pulling to the right and one normal is pushing to the back. Got this? I didn't write in the vertical direction. So this is the horizontal direction ka equation. Horizontal forces is equal to mass into acceleration. Clear? All got this. Let's see one more. We have an incline here. We have a sphere here. There's a wall on the right hand side. This is also mass m. This is also mass m. All surfaces are smooth. Meaning after some time what will happen if you look at the picture, the wedge will move to the right, left. The ball will come down like this, isn't it? So the ball is coming down and the wedge is going back. Find the acceleration of the system.
So both
Both
have
of
the
them. Find
same
the
mass,
acceleration.
right?
Same mass, same mass. Find the acceleration of the ball and the wedge. Assume the sphere is in contact with the wall. It doesn't lose contact. Let's get this. And we have seen this, how to draw the FBD. If you guys remember this? 18A, constant equation, FBD. I made sure to teach you all these things beforehand so that we can just use them directly now. Like I keep saying, if you know how to draw your FBD properly and constraints, I think 80% of the problem is in your hands. How do we do this? Try. I'll give you 2 minutes. I'll give you a minute for the FBD and the constraints. Then I'll give you another minute for solving. Let's see. You must have got the FBD right. And the constraint. Get them first, work on those two. Let's see the free body diagram. There is one normal reaction between them. This is N ground. This is mg. That's it. There are only 3 forces. Here also there are 3 forces. Step 2, accelerations. This guy is going down with A2. This guy is going here, this with A1. You need to find the relation between A1 and A2 now. Acceleration of wedge is g by 1 minus tan theta. Nerotsa, that is definitely wrong. Think about it, Osasi. When you got an answer now, if you put theta 45, you're getting infinity. Doesn't make sense, right? G by 1 plus tan theta could be. Even I don't remember the answer exactly. Anyone else got that? G by cot theta plus tan theta. So, okay, that is something else. I think Utsa and Samek, both of you got the same. Ovia also got the same. Arya, check karo na. 3 people got the same answer. No, I think maybe you also got it. Tan square आ रहा है सबको denominator में. I think you got it right, Arya. I think something else. Okay, let's see the constant equation. How do you find the constants, everyone? So if two solid surfaces are touching each other, then the acceleration along the normal must be same. So this is your normal. So this is going down with A2. This is going with A1. If this angle is theta, this angle is theta, this angle will be 90 minus theta. This will be theta and this will be theta. Geometry there. You can go and check out in the constants we have done this. So acceleration along the normal must be same. So this component will be A1 cos 90 minus theta, which is A1 sin theta. This component will be A2 cos theta. So A1 sin theta is equal to A2 cos theta. This is the relation between the accelerations. So we got A2 is A1 tan theta. This is your step 2. Assign the accelerations and find the relation between them. Great. And then let's find the forces. So if you extend this vector normal reaction here, this is theta, right? And this will be 90 minus theta. This will be theta. So the components will be n cos theta. This component will be n sin theta. That is the n ka components. Similarly, this will be n sin theta. This will be n cos theta. Hope everyone is getting the angles. Check out the angles. It's all geometry there. So for the wedge, I will write the horizontal forces. Because wedge is moving only in the horizontal direction. Which is pushing to the left hand side. So n sin theta is equal to mass into acceleration. That's it. There's only one force acting on the wedge on the left hand side. For the ball, vertical direction. Because it's moving up and down, I'll take only the vertical direction. Mg minus n cos theta is equal to mass into acceleration. Please check your equations. That's your step 3, right? Choose your x and y axis, resolve the forces along x axis and y axis. You're done. So you want to find A1 and A2. So take n from here. N is equal to ma1 by sine theta. Take this and substitute here. This will be mg minus n cos theta. N is nothing but ma1 by sine theta cos theta, which is I think let me do one thing. It's becoming too crowded here. Just let's write the equations here. And this will be ma2 and a2 is nothing but a1 tan theta. M gets cancelled everywhere. We get a1 tan theta plus cot theta. You can simplify this or you can leave it like this. Once you got a1, you'll get a2 also. What is a2? G tan square theta by 1 plus tan square theta. Clear with this? You can simplify it further. 1 plus tan square theta is x square theta, and then you can do all that stuff. That is okay. Any doubts on this? So the main thing is this, the free body diagram, the constant equation, and the equations, and you're done. Any doubts on this picture? Please ask me any doubts on this page. Anyone didn't get the FBD? Anyone not clear with the constraints? Anyone didn't get the angles? Clear? Great. Let's see one more. We have a block here of mass 2m. This is theta. Find acceleration of block m at this instant.
So is the system released from rest?
Writing patience. System is released from rest. We will discuss about that also. What if it is not at rest? Again, still the story is the same. FBD, accelerations, constraints, equation solve. G cos theta 1 by 2, G cos theta by 2 plus cos square theta. We have to, yeah, why karna? Let's see. Step 1, free body diagram. Tension, your own weight mg, normal reaction. Tension, mg. Step 2, accelerations. Let this go with a1, let this go with a2. This angle is theta. Step 2, find the relation between the accelerations. We have to use constraints, but remember, constraint equations is technically valid only for velocities. So if this velocity is v2 and this velocity is v1, luckily here it works out. So when you apply the constant equation here, t minus v1, t v2 cos theta is equal to 0. So v1 is equal to v2 cos theta. Great. Now, unfortunately, you can't directly write a1 is equal to a2 cos theta here. Theta is changing. We have done a question like this. Then what to do? Differentiate on both sides. d1 by dt will be dv2 by dt cos theta plus v2 differential of cos theta. But luckily, you released it from rest. This is 0. You're getting it? So if initially it was not released from rest, that acceleration term will come, it gets pretty messed up. I hope you remember that problem which we have done. This question, if you remember, you cannot directly say, you know, A is equal to U cos theta here. You have to do all the differentiation and do all this stuff. So if theta is changing, you cannot use that thing for acceleration. Since luckily here it became 0, you get A1 is equal to A2 cos theta. I hope you're getting it. So that's it. Because you release it from the rest, it is safe, or else you will be gone. This is 0 since released from rest. Or else the equations will be pretty messed up. It depends on your initial velocity also. Yeah, I think done. You got everything. So resolve the forces in the horizontal. T cos theta. T sin theta, and then write your equations. T cos theta will be mass into acceleration. Here, T minus mg is equal to mass into acceleration. This is your equation 1, equation 2, and equation 3. Solve all of them. You'll get an answer. How much will that be? I'm asking you to find the acceleration of the block M now. So I want to find A1. So I don't want A2. So let me solve it in the next page. The question is over. It is just a matter of solving now. So replace T here. This will be 2ma2 by cos theta minus mg is minus ma1. Then replace A2 here. M goes off everywhere. This will be 2a1 by cos square theta minus g is equal to minus a1. A1 will be g cos square theta by 2 plus cos square theta. Check. That's your answer. Sec theta. Yeah, sec square theta you'll get. If you bring it to the denominator, it is 2 sec square theta plus 1. But anyways, have a look at this, everyone. Did you get the FBD right? That's the first part you need to check. Second thing, did you get the constraints right? Did you get the equations right? Then you're done. After that, you goofed up something, you did a calculation mistake.
Sir,
Oh, yeah.
so could you explain like when you differentiated dv,
Hmm.
then what you did?
Here,
Yes.
chain rule, no? Product rule, right?
I
Here,
want
because
to-
theta is variable and V2 is variable, you have to differentiate both of them, product rule.
No, I'm asking why did you take v2 as
Why did you take V2 as?
I mean I thought v2 why did you take v2 as initial velocity?
No, I didn't take initial velocity. I said V1, V2 are the velocities at that instant. V1 and V2 are the velocities when the angle is theta. Right? And in the question it is given when the angle is theta, they are released from rest. Got it? Yeah. So it is like this, Reovia. Differentiate and then substitute the value of 0. Don't substitute in the beginning. So V1, V2 are variables at a given theta. After differentiating end में, we will put the values of V1 and V2. That is the meaning of it. I hope all are clear with this. So if you had given initial velocity, it would become a much better problem, but the numbers would be more messed up. Next one. So tell me one thing. What does a weighing machine measure?
The normal reaction.
So the weighing machine, right, measures normal reaction. It doesn't measure your weight. And you can type your answer in the chat box, yeah, Claudia. So let others also try. A weighing machine measures normal reaction and it shows the reading N by G. Getting it? So there is a weighing machine, right? And if you're standing there with a box on top of your head, it doesn't show your mass, right? And the weighing machine doesn't know what is your mass. So what it does, it will take your reading, which is here in this case mg, and let's say if there's a box on top of your head, it will take that reading also. Let's say it is small mg. So the normal reaction will be m plus mg. So the weighing machine reading will be, so weighing machine will assume only you are standing, n by g, so it will show a mass of m plus m. Clear with that? So now we have a weighing machine like that in a lift. So you kept a weighing machine and you're standing inside. So when lift goes up, with acceleration a, it shows 72 kgs. So you're standing on the weighing machine inside an escalator, inside a lift. When it goes up with a, it shows 72 kgs. When lift goes down with a by 2, or let's say we'll keep it the same thing. When it goes down, it shows 48 kgs. Find the actual weight or find the actual mass. Are you getting this? So a person is standing inside a weighing machine, inside a lift with a weighing machine on. So when the lift is going up with A, it shows 72 kgs. When it goes down with A, it shows 48 kgs. So what is the actual weight? Hope the question was clear, everyone. Remember, weighing machine measures normal reaction. The lift is going up and down, something gets messed up. Right, Arya. Right, Samyak. But I asked you mass. Right, Shaurya. It's a decent mains level question, right, Siddesh? Let's see. Yeah, 60 is the answer. I think most of you got it. Yeah. Draw the picture. Same story. So the person is standing inside a lift. Let the lift go up with acceleration A. Now, if I draw the FBD of this person, what are the forces? Normal reaction, his own weight mg, and acceleration up. So let's call this thing n1 while going up. So n1 minus mg is equal to mass into acceleration. So we got N1 is equal to M into A plus G. And you're telling me this reading was 72 kgs. That means this was 720 newtons, isn't it? If the reading is 72 kgs, means it must be measuring 720 newtons. Same story, but this time the lift is going down. And the reading is 48 kgs. Draw the FBD. mg, N2, acceleration. N2 minus mg is equal to m into minus a. We get N2 is equal to mg minus a. And this reading is 480 newtons. Two equations, two unknowns. Divide them. M gets cancelled, or you can take out a from there. I think you will get m to be 60 kgs. Actually gave the numbers good, the average it is. And you'll find out a value to be 2 meter per second square. Clear with this? All clear with this? So that there how you handle, problems with weighing machines. Any doubts on this? Great. Let's see one more. This is a problem from HCV. There, so this guy is having a setup like this. It's a decent problem. Let's get this. So we have a box. Inside that you're standing. Inside there is a weighing machine. So here the box, there is a hole. So the string is connected to the box. It goes through the hole and you're catching it inside. And you're standing on the weighing machine. So in this, there are two questions. If the man manages to keep the box at rest, what is the weight shown by the machine? What force should he exert on the rope to get his correct weight? So there are two questions for this. Let's get them. I'll give 3 minutes. First one is easy. I'll give 2 minutes for the 1.5 minutes for the first part. Riyansh, give it a try. Let's try this, everyone. Advai, getting it? Question is clear? Let's try. Aditi, try. $60. No way. What are you talking? Man ka weight is 60. He's asking for reading now, yeah. So you're not supposed to give normal reaction. Supposed to give mass. But you got it. Shaurya. Right, Arya. Right, Samya. Yeah. First part was clear. Right, Devanshi. Most of you got all of you got the first part right. Get the second part also. What was the first part? The man manages to keep the box at rest. So what can you do here? Take the whole thing as a system. If I take this whole box and the man as a system, remember I can choose anything as one system. What do you see? If I take this whole box as one system, you will notice two strings are pulling up, T and T. That's what you will think. There are two strings which are pulling up. Man ka weight is 60 kg, box ka weight is 30 kg. So the total weight will be 900. So 2 times tension is 900. So tension in the strings is 450 newtons. This is for the first part. Now take the FBD of the man. Now if you look at the FBD of the man, that string which is catching, the tension is pulling him up. His own weight is acting down, which is 600. And we have a normal reaction. And acceleration is 0 because the whole system is at rest. And tension is 450. There, from here you can see normal reaction is 150 newtons. So because you're catching the rope and pulling it, the rope is also pulling you up. So your weight actually decreases. At least that's what the weighing machine thinks. So the reading will be N by G. So the weighing machine will show 15 kgs. Is that clear, everyone? So if you keep the box at rest, you need to apply a force of 450 newtons or 45 kgs ka weight ka force onto the string. So if I pull the rope with 45 kg ka force, the rope will pull me up with 45 kg ka force. So the balance weight is 15 kg. So that's what we get. Right, Aditi. Got the second part. Yeah, I think first part most of you got. Samyak, that is wrong. Right, Arya? Yeah, right, Shaurya. Try. I'll give you a minute more for the second part. The second part says, what is the weight shown by the machine? Right? If he exerts what force he should exert on the rope to get his correct weight. So he must be pulling the rope so hard, something he's doing, so that the machine thinks it's the actual weight. Right, Siddesh. Right, Devanshi. Right, Trishi. Most of you got it. So one thing here, if you want to see your actual weight, right, the box cannot be at rest. We saw just now. If the box is at rest, it will show 15 kgs. So we are doing the second part. That means this guy is pulling this thing with so much force, the system actually accelerates. That is the only possible explanation you can have. So now if I take again, I can do both of them separately. I'll take just the man, or I can take the whole box as one system. It still works if I take the whole thing as one system. Tension, your weight is 900 and there is an acceleration. So we get an equation 2t minus 900 is equal to 90 into acceleration. That's your one equation. Now let's draw the FBD of the man. The tension is pulling him up. Your own weight is 600. Your normal reaction and acceleration is up. Because he's in the box, both will have same acceleration. But you said correct weight. Correct weight meaning the normal reaction is also 600 newtons. Perfect. So from here we get T minus 600. N is pushing up. That's also 600 is equal to man ka weight is 60 into A. So we got tension is equal to 60A. Take this and substitute here. That will become 120A minus 900 is equal to 90A. So this will be 30A is equal to, I want to find the tension, right? ठीक है. I'll get A is equal to 30 and then tension is equal to 1800 newtons. So this guy is pulling it so hard, right? The whole system is accelerating up with 3 times the gravity. Clear with this? So I can always take the box and the man as one system. From there, I can figure out one equation and just take the man of an FBD. Remember, you should always take the man ka FBD separately, because if you don't take the man ka FBD separately, you can never write the normal reaction on the man, isn't it? And if you can't write that normal reaction, you won't get the reading of the weighing scale. Are the steps clear, everyone? It's an easy one, but a decent problem. It's a good one. I liked it, so I took it. Clear with this? So that's few more there. So that would be the last one for the day. So next class when we catch up, we'll continue from here. We will do few more problems on this. Then we will go for springs. So till now we dealt with tensions and normal reactions. The spring will be something new. So springs, and then we will see something called pseudo force also. So I think mostly by next week we should wrap up the chapter. I think maybe next Thursday in the second half of the class, if time permits, we'll start off with friction introduction also. Okay, with that we'll wrap up for the day. We have done almost 44 questions. So please make sure to go through the notes first and then start solving your material. I think you'll be able to handle most of the things now, other than springs. Okay, with that we'll wrap up for the day. And there is a test online till 11:30 today. Hope everyone has given it. In case you're not given, it is still online. So give it.